Hi everybody and welcome to the lighting section of the Making E1M1 with ProBuilder tutorial. So here we're going to take a look at how to go through the entire level and set up the dynamic lights, static lights, light mapping, and also some light probes, as well as a couple other custom additions that I had to make this work for recreating the Doom level as close as possible. First off, we have the standard Doom light, which you see throughout most of the levels, this fairly simple cylindrical light. And with this, there were a couple of special considerations with this, mainly because in the actual game you might notice that all of these lights don't actually create any real light. Doom uses sort of a clever, I think it's a projection system or something like that, so these lights are just sitting around mainly as details. For this map though, we needed to have a way to have that light emit from the ring around the top, but also cast proper shadows and not just blast the light straight down to the bottom as if there's no actual cone mesh. So to do this, I ended up creating two separate meshes, one for the main part of the light and one for the lens. And this way I was able to set the light to be on the inside, turn on the light gizmo. So the light is on, or the light item itself is on the inside of the mesh, but it's not being completely blocked by it. So the light will come through and it's not being shadowed out. And at the same time, it's not going to, if we simply turn shadows off, it's not going to just blast out the bottom right below the lights and look completely unrealistic. So this does add an extra draw call and some other performance hits, but I think it's definitely worth it so you get these very realistic, nice looking lights. One thing that I would change though, and I probably will before finally publishing this map, is that the material I used for these is probably a bit too dark and they're not catching any light at all. So I might update that with a lighter material. Since, once again, these lights don't actually do anything in the original Doom game, I had to take a little bit of creative license with placing them around the level where I thought they would work well, and then actually took a couple days of tweaking through these and getting them set up just right. And I think I found fairly good placement to light the map well, but of course, when creating your own, do whatever works well. I went for I think a pretty good balance of keeping it kind of dark and, Doom feeling, but also enough light that you can actually see where you're going as the player. Something important to think about while you're setting up your lights is that it's standard practice and works very well to use lights to guide the player. So whenever you want them to move towards certain areas, place lights there, but not a lot of lights in the other general areas. It's going to pull players in and out and catch their attention. So you can do a lot with just where you place them and how you set them up. So all of these lights, other than one actually, which we'll get to a little later, all of these regular Doom lights are actually static lights, and this means that they're not going to ever move, and I've also set them to never light anything except within a light map. So if we select the actual light itself, back in here, on the light object, you'll want to make sure that static is turned on, so these are going to be baked into the light map. And also set the light mapping to baked only so that they don't have any real-time effects at all. And this makes sure that they're not going to light anything and cost you more draw calls or performance. Of course, the compromise here is that, again, they won't affect anything that's moving in the level. They're only baked in, and we're going to get around this mostly by using light probes so that while you're walking around, you still have some essentially, or what passes for dynamic lighting. We'll get to that later when we're talking more about the dynamic lights and light probes. Now there was one of these lights that had to be set as dynamic, and I've placed that over here, whereas everyone probably remembers there's I don't know the name of that monster. I call them snarfles because they make a funny noise like that. But there needed to be a light up here, and since this platform itself moves up and down, it had to be a dynamic light. So this one is dynamic. So make sure on the light itself, you turn off the static check mark if you're setting one here, and that the light mapping is set to real time only. You'll also want to make sure that the mesh is not static, so it's not going to get light mapped. Next, for the static lights, I used a lot of area lights in this map, and this is the first time I've really used these much. I found them to be a great new addition to Unity. I think they're fairly new, if Unity 4, if not just 3.5 and up. Either way, they're great use, great way to add lights that don't have a specific point and they just come from an area, I guess hence being called area lights, and these can only be used for light maps. They can only be baked in, they can't be dynamic, just because of how they work. It'd be a bit too much of a performance hit for them to be working in real time, at least in the current version of Unity. So I've used these area lights wherever I have the light tiles added in. So I've got one up here, one in the large area up here for this area of tiled lights, same in here, and of course back in this room here, etc. I've also found they work very well for placing right above or next to doors if you need just a little bit of extra light there. And these will cast a very nice, softly shadowed light, almost just like a glow that you can use to easily light areas without getting anything too sharp. And this is important in areas, especially next to doors, because you don't want a lot of light leaking through. Since this door can open and close, it has to be marked as dynamic. So if you're using ProBuilder, make sure and hit M on your keyboard to set that as a mover object, not a detail, world, or any other type. And that way the light mapping will know to ignore it. It's not going to light map it, and it's not going to see it, essentially. This means, though, as we were saying, that any light is going to travel straight through it as if it isn't there. So if I placed a very bright light right here, it would actually travel through onto the other side and look as if the doors simply weren't there. There's actually a case of that over here, but it's not too bad, so I've left it where the red light from this room is traveling through and coming out just a bit over here. This used to be a lot worse until I turned down the lights in this room. It's still a bit there. So you could put sort of a fake blocker there if you wanted to make sure that the light could not get through, or a couple other methods to get around that. But one of the best is simply to make sure you don't have any very harsh and very sharply shadowed lights right next to a door that's going to be opening and closing. One more thing to keep in mind with these area lights is you'll want to manually set their shadows. So for whatever odd reason there aren't any settings here in the inspector when you have them selected, just make sure you open the light mapping window, and here it will give you options for the shadows. You want to set it to on, either real-time, hard or soft, won't matter because they don't cast real-time shadows. And then I do recommend bumping up the shadow samples. Actually, I thought I had these at 3, I'll have to push them up and rebake. If you have any lower, you'll get something like this here, where you have these nasty spotty shadows. And this could also be a bit my light mapping settings. I might need to push the quality settings up a bit, but since I'm using these area lights, I've noticed that you get a lot of these sort of bumpy, speckly shadows because it's a little more performance intensive and you need some higher quality settings for these. So I definitely recommend pushing the shadow samples up a bit. Of course, this will make your light mapping take longer, but it's definitely worth it. Now, the directional light, or sun you could think of it as, in this level, is also a static light in this case, and I did this simply because I didn't want it to be lighting anything more that needed to be just to be baked in, and I'm using light probes for all of my dynamic or pseudo-dynamic lighting. This just saves a few more draw calls and also keeps you from having any kind of light leaks, which can happen when you're using any meshes like this where you have a lot of back faces and not fully complete geometry, which I like to have so that it's a lot easier to work with, where you can see it right down in and through. But unfortunately, some lights will leak through occasionally and you'll get some issues in the corners and edges. So with the sunlight, or the directional light, just make sure and set the light mapping to baked only if you want it to work this way for your level as well. The last bit of static lighting in the level is probably the coolest, actually, the one you can have the most fun with, and that is the emissive lighting. So I've got items like this, which are just a mesh with a texture on it, but they're actually lighting the level. So that would be this here. You can see it particularly well over here with how this mesh or the texture is lighting things up. And even this, I've added some emissive to this, so you can see sort of on the walls. Might not come through in the video, but this very faint blue or purplish is lighting things up as well. And this can give a really neat effect to your level. Almost forgot, actually, one of the best areas here. I found a great way to light this room was simply with the slime pits. So I figured out they're nuclear waste of some sort, they're probably glowing, and they'll do a good job of lighting up this level. So to use the emissive properties of a texture, let's open up one of the ones I have here. Here is the nukage texture, which is used for the slime stuff here. And pretty simple, just make sure you have I would recommend using a targa, give it an alpha channel, and white will glow the strongest, and of course black won't glow at all. And then just set the material to be a self-illum type, and make sure and drop in the texture to both the illumination slot and the main color. As the material shows here, the illumination will come from the alpha channel, that's what the A is showing. And then set the emission, the light mapper property, to a number that you'd like it to, or this is the power, how much light it's really going to emit. The default is 0, so if you're setting this up and wondering why you're not getting any light, you just need to change this setting right here. I found usually about 5 is a pretty good number to start with. If you look at these items, the white lights here are all set to 5. Same for here, well it's one texture, so it's all the same everywhere. And they're putting out a pretty good amount of light. Something to keep in mind though is that these are, as far as I've found anyway, the most expensive type of static lighting. So it won't affect in-game performance, but it will take a very long time to render if you're trying to light a lot of things with these. Also, they're not going to cast any sharp shadows, much like the area lights. They're just going to create a very soft, diffuse light with soft shadows and no harsh, hard edges. So depending on what you want, they may not work perfectly. For a lot of cases though, they're great to have for accent lighting. Another thing this works great for is, I'll zoom in here, whenever you have items like these little computer displays and whatnot, and you want them to always be 100% lit up. So even in this very dark room where you can't see much else, all the little dials and readouts and lights, they're all glowing very strongly, and that's by using the emissive texture. And I've set the material on this to actually not have any emissive properties, so it's not going to light anything, but it is going to always glow through the darkness. So especially if you have a glow filter on, or a screen effect for glow, it's going to come through very strongly and look great in your level. I've done the same for these lights. So the red lights and these white lights both have an emissive property that makes sure they always glow out through the darkness. It makes them really look like lights. Next up, we do have a couple dynamic lights in the level. Number one, there is the light back in the slime room over there, and we have the flashing light here. So if I play the level, so we have this quickly flashing light here at the entrance. And then there's these slowly glowing on and off lights. We'll exit back to the editor to take a look at how these are set up. With this glowing light, or the flashing light, it's just a regular light set to a fairly small range and low intensity, and it has this light flicker script on it. And this script, I just wanted to make sure and give credit to Harry1960 from the Unity forums. He had posted on there for anyone to use, and it's just a simple but great little script for adding on a flicker. You have a couple options, whether it uses noise or a sine wave, or a couple other items there, as well as just a good selection of values that you can customize to make the light just like you need to. So that one has a pretty fast random flashing. And over here we have the other dynamic lights. And these are using a sine wave, so they go up and down on a continuous curve. And I made sure and set the base above 1 so that it never goes all the way down to 0 light. So just like I noticed in the original game, these are always somewhat on but constantly going up and down. Something also to note here is that these tiles also have that emissive texture on them. So they always look like they're properly on. They look like real lights, not just a texture. With these dynamic lights, a couple things to note. Just to make sure that you don't have the static box checked, they need to be unchecked completely so that they're dynamic. And also again, set the light mapping to real time only. So with your lights all set up, you want to move on to the light mapping phase. Actually, before you do that, I would recommend just set all your lights, even the static ones, as dynamic for the first time, and just Obviously check out how your level looks and runs with them all set on dynamic. Don't worry about the performance necessarily, but you'll just need to see how they're going to look. It's very hard to guess or gauge exactly what it's going to look like once fully light mapped. So use them like that just to sort of test and check around. And then remember that once you turn on the light mapping, everything is going to get a bit brighter since the light will be able to bounce if you have Unity Pro at least. So once you're ready to do the light mapping though, first thing I'd recommend is to pick up this handy little light map hack that I found. And this script is credit goes to user The Motion Blur, also on the Unity forums. All sorts of awesome info there. Here's a link to it if you'd like. And he or she had created this awesome little script that allows you to set the max light map size. This can really come in handy since the standard size is only 1024 by 1024, but you're going to run into some issues there with larger maps. They're going to need lots of or many textures, light map textures, versus one single large one, which can oftentimes be much more efficient. So I highly recommend picking up that light map size hack and then set your atlas size to whatever works best for your level. I'm using 4K. I like it all to be packed into one giant texture if possible. With that set, we can open up the light mapping window. And there's a lot here to go through, but in general, basic settings I like to use is number one, directional light maps. This will make sure that you get both normals and specular if you are using those. Otherwise, just single light maps should work fine. I generally don't use dual light maps all that much, but maybe just I don't know well enough. But the single and directional usually work for what I'm creating. When you're first light mapping for the very first time, a good option is to use the low settings, or just leave it on high, and make sure the bounces are set to only 1 or 2. And the final gather raise down to maybe 1000 or 1500. If you go too much below that, it's just going to look bad and you won't be able to get a good idea of what the level is actually going to look like with the final light mapping. So it might be quick, but it won't give you enough actual information. Some other things with the ambient occlusion, usually a value of 0.8 and a max distance of about 1 works pretty well. And having a high level of ambient occlusion is going to give the scene a nice, fairly gritty, dirty look, but it'll have a feeling of something well worn and not too bright and sharp edged. And this works well for a map or a game like this where it's supposed to look run down. For the resolution, I generally go with 35 texels per world unit with 2 texel padding. This works out very well. As you can see, if you zoom in real close, you can definitely see some pixels sticking out here, but it's not that big a deal, and you could use some settings in the interpolation to smooth that out, or just bump it up higher if you have a higher budget for the resolution of your texture, but I found that's a pretty good one to start with. One of the best ways to start out testing your light maps is make sure you don't just bake the entire scene. Select a certain area. For example, I could pick just this area here, and then choose the Bake Selected option. And that way, instead of light mapping or baking out the entire scene, which could take anywhere from 20 minutes to several hours if you have a slower computer or really high settings, this way you can check it out very quickly and see just that area at a time. Another really good use for this is if you happen to mess up on just a single light in a certain room, you don't have to rebake the entire scene. You can just bake that singular area and get it just right, so you don't have to waste, again, hours on rebaking everything. Use that Bake Selected button. I think, at least up till recently, I didn't use it as much as I probably should have, but it's definitely a life or a time saver for sure. Once you've finished baking out your light maps, if you have set the light map size, and like me, you're too lazy to find a way to set the texture import default, you might notice that your light maps, even though they're being baked to 4096, are actually coming in as the standard 1024 size. And this is because the default Unity import max is 1024, so every time after it bakes those light maps, it essentially imports them and crunches them down to 1024, ruining all the hard work that we just went through. So you'll just need to select all the light maps and make sure their max size is set to 4096. Or you could go and do it the proper way, I suppose, and set up your Unity import defaults to 4096. I haven't got around to it yet, but you could do it either of those ways. The last item here, somewhat related to the lighting, is setting up your camera. So if you have Unity Pro, you have the great option of adding a lot of special image effects and such to the camera. First thing there is, of course, don't go too crazy with it. You can easily add way too much. But one thing I definitely recommend, if you can, is to add on HDR. This will make your scene look much nicer and also have things always be fairly well lit, and it can change in between as you go, just as your eyes adjust to real light. In the real world, this way the game camera can do the same. So if you're using Ultimate FPS camera, you just want to make sure to turn on the HDR checkbox and add the tone mapping item. So this you can get by doing Assets, Import Package, and the Image Effects Pro only, if you have Pro that is. And then make sure you add that to the camera under Component, Image Effects, Color Adjustments, and then Tone Mapping. Once that's set, you also need to set the technique to one of the two adaptive techniques. I like the Adaptive Reinhard versus Adaptive Reinhard Auto White. That one never really seems to work well for me. But Adaptive Reinhard should work just fine. And then mix and match with the settings here under the adaptation speed is obviously how quickly it's going to change from one light level to the next. So if you set this a bit lower, it'll just quickly change to the other light level, which can make it more obvious, if you want it to be more obvious, that it's adapting to the light. Or set it to higher to be a little more realistic, where it takes longer to change and the player won't necessarily notice it. Setting the middle gray value is a good way to choose exactly how bright or dark your level is. If I hit play, we'll take a look at this in-game. So unfortunately my camera is moving at the same time as I'm moving this. However, if I take this and let's say I turn it down to 0.06, you can see it's much darker in here now. Or if I move this all the way up to something around 0.5, it's much, much brighter. And this is something you could change from a script if you wanted to dynamically within your game change up and down the brightness that the character is seeing. Could definitely be some good uses for that. I've also added a very slight bloom. Actually, this appears to have jumped back up. I wanted this to be only about 0.2. Just a little bit of bloom can add a lot to the level to make it pop out a little bit more. Once you have your light maps all baked out and your lights set and you've given your level a good playtest or two, then it'll be time to add in the light probes, which you'll use for the pseudo-dynamic lighting. So to do this, first step is just to create an empty game object and then add on under component rendering, the light probe group component. I already have one, so I'm not going to create a new one. And if I click on it, you can see this massive crazy pile of light probes. The best way I guess to explain these is they're simply taking a certain point, so where the light probe object itself is, and then they're checking the light at that area. And then as you're moving through the level or anything dynamic is moving in the level, it's going to use the light from that probe, or actually the area that it's in. Let's see if I can pull it up here. So for example, I have this door. If I select the actual mesh and then turn on show probes and show cells, it's going to show which current cell it's using. So it's highlighted in yellow there. And what it will do is average the lighting that the light probe has found between those two locations. So as the door moves, it's going to change its lighting almost as if there's real dynamic lighting on it. And if you do a good job of setting up your light probes, you'll have a very efficient but also very good looking set for your dynamic lights, or rather pseudo-dynamic. They're not actually dynamic lights, of course, but they do a great job of mimicking the effect. With placing the light probes, you'll need to make sure you have the light probe group selected. Then you'll see the colors change like this, so you can edit them. Simply, for the first one, you'll click Add Probe, and one of these little yellow dots will appear. You can select it and move it around just like anything else. If you hit Control D, you'll make a copy of it, which you can then move to another location. And you want to place these around everywhere that there are major changes in lighting. It's a little hard to see here since I have so many. Looking over here might be a bit easier. I like to place one at about crouch level, so if the player was crouching, then it would light them properly, and one right about head height, so it's going to light them generally correctly as they're walking around the level. And as you can see, I've got them placed all along the changes between shadow and bright light, as well as a few here and there where it's all continuous lighting, but it might be changing just a bit, and we want to make sure that the player or whatever dynamic object is getting the correct lighting. As you can probably guess, this is a pretty tedious, long process setting all these up, and you might want to use multiple separate groups. I've used one for this entire level. Probably a better idea to use multiple separate so you don't have these giant connections going everywhere. To be honest, I'm fairly new to using light probes a lot myself, but I've already found them to be an awesome way to mimic that dynamic light effect, and very, very efficient. So you'll cut down a lot of draw calls and also just make your level run and look great at the same time. So fairly tedious to place, but once you have them in, it'll make for a great effect. And just make sure you're adding them wherever there are major changes in light. So that, and you can even see right on the little spheres here, they're showing what the lighting is at that location and basically how they're going to light the dynamic objects nearby. As you're building your light probes, you don't need to rebuild the entire light maps. Once again, there's a handy little option here. You can choose just bake probes. That'll instantly rebake all the light probes that you have in the level, and it'll take a very short period of time, even with something this large, or all these light probes I have set up. I think it's about 10 or 15 seconds. Not too bad at all. Certainly much better than rebaking the entire scene. So that's it for lighting this level. Once again, it's going to be lots and lots of just setting up lights, tweaking, trying to get it to work just perfectly. It'll take quite a while. Again, this took me several days to get working fairly well, and I'm sure there's lots more that I'll still try to change on it. Something to notice here is that with those light maps baked into everything using the light probes, we're running at a really nice, usually under 50 draw calls in any given area, which is a great way to be running a level. It'll work actually even fairly well on mobile with this low. We could probably get it a bit lower with various other performance improvements. And also this is using the new Umbra occlusion, which is awesome to have, so check out using that as well. But anyway, with the lighting, experiment. Use things like the emissive mapping. You can get some really cool effects using just that. Just keep in mind, of course, the limitations of static only, and it's not going to cast any sharp shadows like these. And make sure and set up those light probes so they work well on your dynamic objects. All in all, I think this turned out pretty well. Like I said, I could spend hours or days more tweaking it, but I'll probably call this done and start working on some more optimization tweaks. So thanks for taking a look, and we'll see you guys in the future tutorials in the E1M1 series. Thanks for watching.